yourself, oh, what's homework? And they went, well, I'm not going to say anything because I don't want to have homework. Maybe, you know, he's an old man, maybe he'll forget. How'd that work out for you? Thinking that way. You still got to do it, don't you?
Yeah.
Yeah.
We have a week instead of 2 days.
7th period, they won't have any homework over break.
They'll forget it.
How nice.
And when is the best time to do this?
Tonight.
The night
Tonight, before you come back, right?
Make sure you remember
Because
it.
probably you're better prepared to do this, and if this were a test, you'd want to do it right now, wouldn't you? Probably you're better prepared to do this worksheet than you will be in 10 days, right? But then on the other hand, it'll be a great way to get your head back into the chemistry, huh? Right? This is all about the KW calculations, the calculations of hydrogen hydroxide equal 10 negative 14.
Wait, do we have to do the whole
and
thing?
Calculations, that's what this is about.
Are you telling us to do something that I before?
Well,
It's not a project.
well, let me tell you a little story. I did a few term papers in my time. Can't you imagine, right? And did I pretty much leave until the last minute? Yeah, that's what I did. There were a number of times when I was running around, because we didn't have computers at the time, running around trying to find someone to type my term paper because I didn't type. Right? That was you had to do it on a typewriter. You ever seen one of those? Yeah. Okay. So the very last term paper that I wrote when I was a senior in college, the very last term paper, I was running around the day before, the day before it was due, trying to find someone to type it, because I had written it in the previous, 36 hours. And we were given 2 months to do it.
Of course.
Did you get that? Did you get that?
Sure.
Not important to the story.
I had lots of time where I wasn't a very good student. I sort of floated through high school. I had like a 2.7 grade point average, graduated from high school. Went to junior college, I grew up in Sonoma, didn't really care much about being in college, or, wanted to hang out with my girlfriend. Especially bad because college was the only way you could stay out of the draft. You know what that means? Vietnam War was on, and if you weren't in college and you were able-bodied, you got sucked into the military. So after a year at the junior college where I had failed a bunch of classes and dropped a bunch of classes, I had a total of about 10 units with a 1.8 grade point average, and I joined the Navy. I joined the Navy to keep from going in the Army and going to Vietnam and fighting in the jungles of Vietnam. And after spending 6 years in the Navy, I got out and graduated with honors with a degree in mathematics and chemistry. Kind of a different guy.
Army changed people.
I wouldn't recommend my recipe to everybody.
The Navy, the water.
That's what the armed forces.
No, that's the air.
No, the
The armed forces suck.
The fuck up, Brian.
What would I have been like if I hadn't gone in? I have no idea. I don't believe it's the armed forces that turned me around. I think it was just the fact that I went into the Navy at the age of 19 and came out at the age of 25, and I had a different perspective on life at the age of 25, as you all will have at the age of 25, compared to what you have now. Undoubtedly. Just real quick, since we have a couple of minutes. It's okay, you don't have to add this stuff to your notes. Oxides of nitrogen, oxides of sulfur. They were, when we added them to water, they produced acidic solutions, didn't we? Didn't they? They are called acidic oxides. And all the acidic oxides are oxides of nonmetals. Chlorine oxides, bromine oxides, nitrogen oxides, potassium oxides, sulfur oxides. When we dissolve them in water, they make acidic solutions. They're all acidic oxides. Now, if we make oxides from metals, sodium oxide, potassium oxide, magnesium oxide, when we dissolve them in water, guess what happens? They become basic. Why? Because all these dissolve and separate, producing what common ion? The oxide ion. And if you looked on your table of bases, the oxide ion is almost all the way to the bottom on that list. It's a very strong base. So when we dissolve anything that has oxide ions in it, assuming it dissolves, many metal oxides don't dissolve very easily, these do, but any oxide that we dissolve in water ends up producing oxide ions, which grabs hydrogen ions from water and makes lots of hydroxide ions and makes the pH high. Okay, now, an interesting application of that. When you burn a piece of wood in your fireplace, you make two kinds of substances. One that goes up the chimney and one that stays in the fireplace. There's the gases that go up and the solids that get left behind that we call ash, right? If you took the gases that went up the chimney, which include water, carbon dioxide, but also oxides of nitrogen and sulfur from the nitrogen and sulfur and phosphorus and other nonmetals that are in the wood, they all go up the chimney because nonmetals, when they combine with oxygen, make molecules. Yes? And molecules don't stick together that well. They end up being gases going up the chimney. And because they're nonmetal oxides, if we dissolve those gases in water, it would become acidic. The ashes are left behind are the oxides of the metals, because they make ionic compounds. And ionic compounds don't make molecules. Instead, they make these ionic solids, where all the ions are surrounded by other ions and surrounded by other ions and all that, right? So they end up being solids and left behind. So if you took ashes out of the fireplace and dissolved them in water, the water becomes basic.
Is that why they're used for making soap?
Because what do we have to do to make soap? When we make soap, I'm glad you brought it up, we take fatty acids that are in fats. We make soap, not detergent, but soap from oils and fats, animal fat, vegetable oil. They contain molecules that have a very long carbon chain, typically 20 to 30 carbons, and then end in this group right here. They are called carboxylic acids. Those would all be hydrogens. If we put double bonds in the fatty acids, they become unsaturated fatty acids because they don't have as many hydrogens on them. If they have more than one double bond, we call them polyunsaturated fatty acids. Terms you've heard before. If it has one double bond, it's called a monounsaturated fatty acid. That has to do with fats in foods, right? Saturated fats have no double bonds, like animal fat. In any case, these molecules don't dissolve in water very well. This end is polar, but not quite polar enough to make up for the non-polar end. So what we do is we have to strip that hydrogen off of there so that we have a negative ion, and that makes it so that it's much more soluble. Now, why does this help us with soap? We have an end here that is very soluble in water, and we have an end here that is very nonpolar, and therefore very soluble in nonpolar things, like grease and fat. So when we put soap in water, it will dissolve because of this end, but if there's any fats or oils around that wouldn't dissolve in water, this end will dissolve into the fat, and the process of doing that will actually break up the fat into little tiny droplets. Each droplet of fat has all these little molecules dissolved in it with their polar ends on the outside of the droplet of fat that the water molecules can attach to and carry it away. That's how soaps and other surfactants detergents work. They have an end that's polar that dissolves in the fats and greases that we want to wash off our dishes and clothes, and a polar end that sticks out of these little things that makes the globules easy to carry away by the water. Okay? Now, we take the fat, and to remove that hydrogen ion, we need a base. And the ancients figured that out. They had animal fat, they had ashes from their fireplace, and somehow or another someone figured out when you mix those together, you made this stuff that was good for cleaning stuff. Have a good break.
How do you turn it? Get in here. Oh my god, it's super zoomed in. Oh. Hiya. Hi guys. Wait, okay, this one's for Abby. Oh, it's like backwards. Good job, Amanda.
Oh, I'm really smart. Do you like it though? Can you read it? So she can.
I think. Wait, sideways.
Look
Okay.
who's weird out now.
Okay, and to Stefan, I hope you're having fun. I think you're in Hawaii. And
That's really not fair. Everybody's on fun trips.
Blake, you sit there. That's your seat. You're in, where's he? Ecuador. Have fun.
Yeah, I'm
Okay.
really
We should
jealous.
leave. We're
I
the
could've
only
been
people
on that
in here
trip.
right now.
Yeah.
Okay.
Yeah.